Hello, my name is Dr. Dan Mason. I have a PhD in Public Policy and Administration. This video will review how to lie like a scientist. Lying like a scientist can be interpreted as using scientific language, data manipulation, or selective reporting to mislead without outright fabricating information. This approach can be particularly insidious because it leverages the credibility of scientific discourse. Here are steps to do this, but remember, the intent here is to illustrate potential misuse, not to encourage unethical behavior. Misleading through science is fundamentally wrong and against the principles of integrity and honesty that science upholds. 1. Selective data presentation. Cherry-picking data. Only present data that supports your argument. Ignore data that contradicts your desired conclusion. For instance, if you want to show a new drug is effective, only highlight trials where it showed positive results and omit those where it failed. Graph manipulation. Use graph scales to exaggerate effects. For example, choose a y-axis scale that makes small differences appear large. Use cumulative graphs instead of periodic ones to mask trends or declines. 2. Misleading statistics. P-hacking. Conduct multiple statistical tests and only report those with significant results, even if they are due to random chance. Adjust variables and data subsets until you achieve statistically significant outcomes. Misrepresenting correlation as causation. Imply that a correlation between two variables is evidence of causation without proper evidence. For instance, if two events happen simultaneously, suggest one causes the other, without ruling out other factors. 3. Ambiguous language and jargon, using vague terms. Use technical jargon and complex language to create the illusion of credibility and hide the lack of concrete evidence. Ambiguous terms like may, could, and potentially can make weak evidence seem stronger. Overgeneralization. Make broad claims based on limited or specific data. Suggests that findings from a small, non-representative sample apply to a general population. Extrapolate results from animal studies directly to humans without acknowledging differences. 4. Strategic omission. Withholding key information. Omit details about the methodology that might reveal weaknesses in your study. Leave out the context that might help the audience understand the limitations or alternative interpretations of the data. Ignoring confounding variables. Do not account for variables that might affect the results. Present your findings as more robust and straightforward than they are. 5. Authority and peer review. Appeal to authority. Cite experts or institutions selectively to bolster your claims while ignoring dissenting opinions from equally credible sources. Use the reputation of well-known researchers or prestigious journals to give undue weight to your conclusions. Exploiting peer review. Submit papers to less rigorous or friendly journals where you know peer review might be more lenient. Exploit that peer review cannot catch all instances of selective reporting or minor manipulations. Conclusion. While the tactics described above show how one might misuse scientific methods to mislead, it is crucial to emphasize that such behavior is unethical and damages the credibility of science. True scientific inquiry is built on transparency, honesty, and integrity. Misleading through scientific discourse deceives others, undermines trust in scientific research, and can lead to real-world harm. Always strive to uphold the highest standards of scientific ethics and integrity. Thanks for watching my video. Please leave a comment, like, and subscribe for more videos like this one. I hope to see you on the other side. Take care.